Yeah, thanks for the introduction. So I'm Tomasz, and those slides are online. You can find them if you go to like tomasz.eu and like click up a couple of links to like my personal site and then on talks. And this is the latest one at the top of the list. This is a talk about using SQLite in production, something that's been a pretty hot topic in the Rails community since half a year now, which is not a lot for some, especially if you remember that SQLite has been always a second-class citizen in the Rails world. It's been always considered to be sort of like a toy database meant for development and test, for playing around, because it was easier to set up, because there was zero setup involved. It was easier to set up than MySQL or Postgres, the serious databases. But yeah, the general consensus in the Rails community was that SQLite is not meant for production web apps, and for a couple of good reasons. The thing is that those reasons are no longer where they were for the last 14 years, 15, 16. We're going to have like a short history lesson on SQLite and Rails in a second, because I was there, Gandalf. So yeah, SQLite is a serious database now and can be used in production. I'm going to show you like a couple of reasons why, a couple of ideas how to, where to begin, and what are the not necessarily steps to run it, because it's very easy. And now in Rails, we just have like a Docker file. So we just do like a Docker build, Docker up, and the application is running in production with SQLite. But there are a couple of caveats. And also there's a big question, why would you want to use a toy database instead of a serious one, if the serious one is still available within the reach of our hand? But yeah, let's begin with some history lesson. I'm old now. I'm going to be 40 this year, so I've been here for a while, and I'm now at this side of argument that it sometimes helps to understand where we are when we like check out where we've been before. SQLite actually started as a military grade technology, which is like a very serious thing to say. But yeah, it actually was started by its original author when he was contracting on the USS Oscar Austin, a battleship, rocket battleship, I think it's called, missile battleship. I'm not an expert on military. And there's a pretty awesome podcast interview with him at thecorecursive.com, episode 66. SQLite with Richard Hipp, the author, and there's a story on how they got the original, not only the idea, but the original need for SQLite. Basically, they needed a local database in a remote part of the ship that would be more resilient and that would still work, even if the connection to a server, to the original core database server at the other end of the ship, was flaky or down, which is like sometimes when you're in a battleship, you want your ship to work regardless of whether a server is reachable or not via a network cable, a flaky network cable, because that was a long time ago. Again, all the slides with the links, with clickable links, you don't even need to copy paste it, are on the site that I've shown earlier. So please go ahead. So yeah, great episode and a great story, like how SQLite was conceived. If you don't want to listen to a podcast, if you don't like the spoken form, there's a transcript, and if you don't like the speech format, there's an article on Wikipedia also outlining how it started. And SQLite, in the meantime, between the battleship story and today, became a default database in our browsers. Like if you actually check what's running underneath every Chromium-based browser, and today I think even Microsoft Edge is running on Chromium engine. There is an SQLite database where your settings and a lot of other stuff is being kept. You can interface with it using it's being included using a WASM build of SQLite. So it's actually all within a browser using like a WASM, so WebAssembly, and still it's an SQLite code written originally in C, compiled for WASM. And you can interface it, of course, using your browser's tools, but also using external tools, because SQLite database, as you might know or not, is just a single file, which makes it very different from other database engines. It's also default on our phones. Like every application on our smartphones, both iOS and Android, do store their local data, their application data, in a dedicated SQLite database, well, slash file, because in SQLite the entire database is a file. So it's serious enough to be the database on the browser. It's serious enough to be a database for every phone app. It hasn't been serious enough for a very basically simple reason in web applications. So there's also a funny piece of history that Rails 2.0.2, which is like ancient times for most people, in December 2007. So you can calculate yourself how many years ago that was. My math doesn't go that high. That SQLite 3 actually, with a couple of like new features, became the default database for development and test environments in Ruby on Rails. That was again December 2007. The original blog post from David is still there. The screenshot has been basically like made a couple days ago, so it should be still there. But yeah, it took it a couple of years, right? Like 16 and a half, 16 and something, until SQLite tooling and support in Ruby on Rails started to be robust enough, and everything started clicking together so that SQLite is now considered production ready in Rails, and there's tooling for it. And it was a big part of DHH's keynote at Railsworld in October last year. So what happened in those 16 and something years? And what didn't happen? What had to happen? And why couldn't we use it? Well, we could, but like, why didn't we use SQLite in production since then? By the way, if you remember Rails 2.0.2, you had a great childhood, great adolescence, but like, please get yourself checked. Like, you know, I know that many people have, you know, like neglected their health checks because of the pandemic, because the health system had more important things to do, but it's no longer the case. So, you know, yeah, please take care of your health. If you remember Rails 2.0.2, your health is not perfect, let me tell you that. Anyway, if you watch DHH's keynote from Railsworld 2023, and it's like an hour long, so there's actually like a timestamp for the last 15 minutes if you want to just boil down to the core of my talk around SQLite. DHH and the team at Basecamp, 37 Signals, I don't know how the company is called this month. They've been working on a couple of new tools for Rails to make things simpler, to stop relying on external tools like Redis and a couple of not delayed job, but like Sidekick and other stuff like this, using the fact that ever since Rails, you know, 2.0.2, so since 2007, we had a couple of revolutions in storage hardware. Like back in 2007, again, if you remember those times, if you don't, let me just tell you, we used a thing called hard disk drives or like spinning disk drives. Like you can still buy them, especially if you're running like a network attached storage or like a bigger system or like anything like this. But you know, for the kids in the audience, that was like a very slow and very and way slower than actual RAM way of storing files. And that was the only way of storing files available. But since then, we got to you know, drives called, basically we have like now 5th generation of NVMe, and they are, I think, something like 100 times faster, because hard disk drives could achieve something like 100 megabytes per second. 5th generation of NVMe drives can achieve something like 10 gigabytes per second, which basically is like a, yeah, it's a 100-fold increase to 2 orders of magnitude, which basically like narrows the gap and brings the persistent storage closer to RAM performance, which basically prompted DHH and team at Basecamp to build 2 tools that are powered by SQLite, so basically powered by a disk-based storage, not a RAM-based storage. And they built Solid Cache, which is basically like a caching layer. And I know, like, everybody always consider caching to be something that resides in RAM because of the speed, but they actually built something that's supposed to be a cache. Well, it is. It's there and it works in SQLite. So basically, again, in a disk-backed environment on NVMe drive, and they've achieved results in their benchmarks for like their actual use cases that were maybe 30-40% slower than a cache in Redis, which is a pretty impressive result. Like, it was good enough. Like, they had a difference of cache fetching between 0.8 millisecond in Redis versus 1.2 millisecond in solid cache, like in SQLite on disk. So they went with it. They've actually like removed Redis as their caching layer. They got rid of Redis, of memcached, and they went with a couple of their apps with solid cache. And they've also started building solid queue. Queuing systems in Ruby on Rails have been always like pretty much like a pain point, because queuing systems, again, if you remember the year 2007, were a piece of shit in all of the web. And basically all the internet was rediscovering how to build a proper job queuing system together with, not just Rails community, like the other technologies also struggled with it. So there was like, delayed job database back, but like kind of slow. It relied on a couple of hacks and database logs. It worked, but it was kind of slow. So then when Redis came up, Sidekick appeared. Like first it was Rescue and then Sidekick, and again, faster for fetching jobs. But anyway, 16 years later, SolidQ, the team at Basecamp at First Signals, did a job queuing system in SQLite with like all the proper features that you would expect from an active job backend, which basically means avoiding a race condition of two workers fetching the same job at the same time and performing the same job at the same time twice. And again, they did it in SQLite, and it's performant enough to ditch Redis-based solutions, or like non-persistent storage-based solutions. So again, this talk, again, slides are online. You can click it. You don't even need to browse to 4656 because the URL is already for this timestamp. So just less 15 minutes. Great keynote. Anyway, this actually prompted me to look into SQLite, also because for the last 2.5 years I was working at a pretty large Ruby company, and there was no SQLite basically. Everything was kind of big and kind of at scale, and everything was kind of complex, and there was a very long arm between what I was doing and what I was writing and when it was running in production, and debugging was also a pretty convoluted process, like inspecting what was going on. And I've started longing and looking for like simpler solutions, ways for me to build web apps again on my own, deploy them on my own, and do something that, again, the HH called in this talk, make Rails a single developer framework again, so that you don't need competences out of 20 different fields in order to be productive and to build something. So I started building some smaller apps and see if I can run them myself on my network attached storage on a mini PC, running in my bedroom without any fans and stuff. Anyway, but whenever someone mentions SQLite, people's reaction, and by people I mean like mine, for example, for the last 15 years, was I can't use it because I can't use it because it's slow and it's locking. And actually, there was a time in SQLite when a single write, because remember, since SQLite is a single file, it means that only one thread can change this file, which means that basically there was a lock on a process level, on a database level. Other database systems usually have a table or database spread across multiple files, which means that there can be writes happening to different tables at the same time, different files. But SQLite not only has that write is there at a given time, but also what was happening before, a couple of years ago, was that if a write was happening, nobody could also read from it. So the lock was pretty global. It blocked also the reading. So SQLite was recommended to be for single user applications or applications where the ratio, the proportion, the fraction of reads to writes is heavily in favor of reads. So for example, 10 reads to 1 write, 100 reads to 1 write. This sort of numbers, because the moment you started to get write heavy in SQLite, you couldn't even read it back. Because again, a writing operation blocked also the reading operation. This is no longer the case. A couple of years ago, something like in 2010 actually, but yeah, nobody was following it, SQLite development. Write-ahead log started to be added to SQLite, which is exactly the mechanism that's used in a lot of file systems, and also what's exactly used by Postgres. Write-ahead log is basically like a journal. Like if you have a journal file system, the application driver layer basically writes that I'm going to now write this, and then this is being written in a single atomic operation, easy to roll back, and it stopped blocking the read operation while write is happening, which is great. SQLite has atomicity of its write transactions. Actually, it's like fully ACID compliant. So it's and actually SQLite, if you look at the features and if you look at the guiding principles that the developers of SQLite are following, they are asking themselves a question regularly. If you even like read the changelogs or like read the discussions, what would Postgres do? This is like their core principle, which basically means that SQLite is not like a worse MySQL, it's sort of like a lighter Postgres, which makes it a pretty awesome database. Like in personal ranking, this puts MySQL on the third place, not on the second. Even stuff that I was researching like recently when I was building a very simple app to download YouTube videos, to watch later, to watch offline, and not to rely on the application. It still needs to be online to check if I can still watch my offline downloaded files, which is absolutely fucking stupid, but like this is the way a lot of streaming services do it right now. It supports JSON columns. It actually even supports JSON-B columns, which basically means that there's like an internal binary representation of JSON data that's like structure aware, and that allows for faster operations within the functions operating on JSON data actually are more structure aware. They don't just parse the string like character by character. SQLite even has like full text search engine, and it's now in its fourth iteration. The third one and the fourth one has been contributed by Google, and it's very performant. Like you might not even need an extra full text search engine, like whatever flavor of Solr is popular right now. Like it was again back in those years when Rails 2.0.2 was released. It was it was called Ferret. Now it's Elasticsearch. This is all Solr. Like if you look enough layers down, it's all Solr. But anyway, you might not need Solr. You might not need any other dedicated full text search engines. So you can basically have your job queue backed by SQLite. You can have your cache in SQLite. You can have your full text search in SQLite, like basically like a one-stop shop. So what's stopping us from doing it? Yeah, the tooling. The tooling is pretty young. The tooling is pretty young and pretty recent because people haven't been running SQLite in production a lot. So if you want to try SQLite in production, if you want to see what the tooling is now capable of without having to resort to a lot of manual work, two other things to check from Basecamp's 37 Signals GitHub account: Solid Cache and Solid Queue. So if you need a caching layer, check out Solid Cache. Maybe you don't need to start up a memcache process or a Redis process. Solid Queue, maybe you don't need Redis, maybe you don't need Rescue, maybe just Solid Queue will work. There's actually like an entire almost like suite, even though I hate the word because for my generation it meant Microsoft Office. There's a whole suite of tools and applications for SQLite using Rails applications called LiteStack, which basically covers cache jobs. Basically is an active job backend. Like this is the first question you need to ask yourself. It's going to be like a custom stuff like Sidekick, which actually avoids being active job compliant because they need to sell the paid features, the premium, and they wouldn't be able to if they conform fully to active job API. But LiteStack offers basically cache jobs, full text search engine. I'm not sure if it's the one built in SQLite, so that's I'm flaky on this one. And also an action cable implementation, which basically means you also don't need to start like another process, for example, for exchanging messages using WebSockets with your client, with your application. Basically, I basically started this entire search and delve into SQLite because I wanted to just build my own application that's going to just run on my network attached storage box, and where I can just drop in URLs of YouTube videos they want to see later, and that we will just watch on my TV with subtitles downloaded and stuff. So it's a very simple app. It's backed by SQLite because it just stores the URLs because the actual files are stored in the file system. And yeah, I'm running it. So if you ask me if you have an SQLite application running in production, sure I do. It's just that it has like 2 users because there are that many people in my household who can use a computer. But yeah, it has a Rails end production if you check it. So counts, right? And we're heading to the end of the talk because I wanted to keep it brief. I also don't have a lot of interesting things to say, as you might see. So there are a couple of limitations. Is a very strong word. It's not a problem; it's opportunity. So there are a lot of opportunities for going with SQLite in production, and there is actually like a developer at the Fractal Mind GitHub.io. Great blog, by the way. You should totally like, subscribe, or like, whatever we're doing with vlogs these days. There's a big blog post from like a week ago. See, this is not a talk made by, by a boomer 15 years ago. It's actually fresh. He has a blog post on basically pushing the limits of using SQLite in race applications up to a point where he basically makes it work with 32 consecutive threads trying to write into the same SQLite database, which means file, which puts some limits because because then SQLite builds a queue of what needs to be saved when, and then it times out some of the processes, so they need to retry, and there needs to be like this exponential backoff algorithm, but he still doesn't want it to throw errors. So he started pushing SQLite into what it was like never designed to, and he started working on having Rails with some better defaults, and he shows what configurations in Rails is better if you're going to have not like a write-heavy application, because if your application is write-heavy, don't use SQLite. But let's say a write, more than one write at a time happening. He also links a lot of his previous blog posts because he's been actually he's been basically one of the maintainers, one of the developers in open source behind SQLite free adapters, enhanced SQLite free adapters, and Rails defaults. So if you're going to read one thing about using SQLite in production, or like have like a single resource, he's also showing how he's profiling it, what tools he's using for measuring A, performance, but also B, reliability. So like if he doesn't get timeouts and stuff. So yeah, again, great blog post, and again, you can just click the link if you open the slides online, and yeah, and there's of course like the last question, where to run it. Answers of course like everywhere, and DHH even mentions the name called Heroku, which is again not very popular with the younger people today for a very good reason. But when if you have a Rails app, you now have a Docker file. So like so you just drop like Docker build, Docker app, and you can even run it on your like network attached storage. It's going to run in an isolated file system. It's not going to impact your files. This is how I run it. There are like hundreds of Dockerized applications that everybody can run, and you can build your own. Some routers actually allow like run some like bigger, beefier routers, or like some other network hardware actually allow you to run some Dockerized systems. Or you can just have like a mini PC which has like no fan. It's like super quiet because it's not going to be noisy at that point. Just plug it somewhere in your home. Yeah, it's also like a gateway drug to starting a home lab, which I am not sure I'm going to recommend to anyone because it's a new hobby. But yeah, like again, there's the entire thing about SQLite is that like there's no configuration to run it, because you don't need to run it, because if your Rails application boots up, it means that SQLite process is basically started, because this is the application process, and there's no deployment how to, because if your application process runs, then it means that your SQLite process is also run, because it's a part of the application binary. So that's going to be basically it. Thank you.